All right, so now what we're going to do is we are going to look at inverse trig functions. We're going to talk about their graphs and using them and some of the issues that come with using them that you maybe haven't run into yet. This will be our last lesson in Chapter 7. It's a pretty short section, and with the MCAs happening, we're going to push our test until the week of May 3rd through May 7th, so it doesn't overlap with any MCA testing for a lot of our students who are doing that. So if you are interested in the calendar, those are posted for this week, and you'll have the next ones upcoming. We're going to do only 2 sections of Chapter 8, and that's what we're going to do next week. And then again, giving longer time on both this quiz and next week's quiz because of the MCA testing. And then we'll look at a test on ideas from Chapters 6, 7, and 8 on the week of the May 3rd through 7th. So get yourself ready for notes, and we're going to get started. Now, one thing we're going to talk about first is graphing the inverse trig functions. Now, if you remember from our previous discussion of inverse functions, is that if I'm looking at just like a basic graph of a function, its inverse is reflected across the line x equals y. And so its inverse graph in this case would be something like this. Not the greatest drawing. But what you can imagine with graphs like cosine, sine, tangent is that if I just drew the graph, so let's start with cosine. So here's our x and y axes. Now if I just draw the graph cosine, if I reflect that over the line, x equals y, I would have a graph that goes like this. And as you can see there, that absolutely fails the vertical line test. So what we're going to do in what cosine inverse and sine inverse, how they work, is that they only take a certain interval. So if you think about this, you're only ever going to get cosine inverse answers from these points. So it's just that blue section. And so its domain of cosine inverse is the interval -1 to 1 on the x-axis, and its range is 0 to pi on the y-axis. So here's pi, here's 1, here's -1. So a much smaller section. If you think about it in terms of the unit circle, you're only going to get back values between 0 and pi or 0 and 180 degrees if you use cosine inverse on your calculator. Cosine inverse isn't the one that gets students actually in trouble all that much. It's sine inverse. So sine inverse does the same thing, but so we're still looking at a domain from -1 to 1, and we're going through the origin just like sine would. But here we're going through like this, and we have our bounds at pi over 2 and -pi over 2. So in terms of the unit circle, I'm always going to get an answer in those 2 quadrants. Now this is a problem because then you maybe are asking for sine inverse of 150 degrees. Well, that's not in there, right? So you have to deal with your fact that you're going to only be able to get answers out in that range. Lastly, tangent, and this is going to show up a lot for those of you who are taking calculus, is that tangent, because it had a vertical, if you remember, it has vertical asymptotes, regular tangent, tangent inverse has horizontal asymptotes at the same values. So we'll have a horizontal asymptote at pi over 2 and at -pi over 2. And then the figure itself is going to look like this. So its domain is all real numbers, so -infinity to +infinity, and its range is negative pi over 2 to pi over 2, just like sine. So this function you'll see a lot of in calculus if you're choosing to go that way. Now, for the most part, your calculators are going to be able to be of use for this. Now, the important point is for you to be able to do this without your calculators. So, let's show like one of the few places where you're going to run into a trouble, and as I said, it's usually with sine inverse. So sine inverse of negative root 3 over 2. If I'm doing this without a calculator, I'm going to look at my unit circle, and remember sine inverse is only in quadrants 1 through 3. And negative root 3 over 2 would be here. And so we are close to the y-axis. So our reference number is pi over 3. And then I just have to ask myself which one it is. And since it's negative, because our range that we're looking at, our range is negative pi over 2 to positive pi over 2. So some of you might have found the positive value for this point, which would be 5 pi over 3, but that's not in the normal range of sine inverse. So this is negative 1 pi over 3. So sine inverse of negative root 3 over 2 is negative pi over 3. Now, sine inverse of sine. Now, what you might remember is that inverses cancel each other out, and this is for the most part true. Now, this is important here, is that pi over 4, if I'm considering sine inverse, pi over 4 is right here. This is in quadrant 1, so it checks out, right? You can use this sine inverse function in quadrant 1, and so then they can just immediately cancel out, and you get pi over 4. However, if you have sine inverse of 5 pi over 4, 5 pi over 4 is going to be here, which is not in the range of sine inverse. You'll notice it's over here. So you can't just cancel out. What you can do is you can evaluate. So you can say, all right, well, what is the sine of 5 pi over 4? Well, that's negative root 2 over 2. Now, if I get negative root 2 over 2 in the range, it's right over here. You'll notice that they have the same y value. They have the same sine value. So this would give us sine inverse of negative root 2 over 2, because now we're in the correct range for this function. And that would be negative pi over 4. So what you'll notice is that you're always going to have the same reference number when you want to cancel out, but it's not always going to be exactly equal. So watch out for any values like this where they are not lining up in the specific domain and range. And if you are worried, you can do the steps in progress like that. If you have questions about inverse functions, please let me know, and I'll be available on Zoom, email, or in the comments.